So today we're going to talk about logarithmic functions. This is section 4.6 in your book. We're going to talk about converting between exponential and logarithmic functions, and we're going to evaluate logarithms of numbers. We're also going to graph those logs and give their domains and ranges. So the first thing we have to figure out is, what is a logarithmic function? So we start out by looking at exponentials. You remember that an exponential function is some number raised to a variable power. And we always said that a had to be bigger than 0 but not equal to 1. And that our exponent was going to be bigger than 0 also. Now if you recall, we talked about we had exponential growth. This was where a was greater than 1, and we talked about exponential decay, where our a was between 0 and 1. Now, what is an inverse of a function? Well, if you remember, we had this inverse identity, our line y equals x. And if we use that identity and reflect across that, we get our inverse function. So what we have here, if we reflect this, we get something like this. And if we reflect this one, we get something like this. What do we call these inverses? So this is the inverse, but what is it? Well, this inverse for an exponential is a logarithmic function. So the inverse of an exponential is called a logarithmic function. Most of the time we just refer to it as a log, because it's kind of a long word. We write this function log, and then we have a base here, the same base as we have for our exponent, base a of, well, let's not confuse it here, of y. And what this is if we have, let's say we have y equals a to the x. When we switch these so that we can get our inverse functions, we switch our x and our y, but we need to be able to solve for y. So now what we do is we say log base a, use the base, the same as the base for the exponent, of this number x equals the exponent y. So here's our inverse. So we switch our x and y, and this is what we resolved. If you have a exponent and you want to change it to a log, the base goes down here, the base of the exponent, and then this is the number that it equals, and then the exponent is your answer. So let's try a couple of these. Let's say we have 2 to the 6th equals 64. If we want to change that to a different way of expressing it, express it in logs, then we have log, our base is 2, our answer is 64, and our exponent is 6. We have 3 to the negative 3rd equals 1 over 27. We want to change that. Our base is 3. Our answer is 1 over 27. And our exponent is negative 3. If we have a log, let's say we have log base 2 of 1024 equals 10. we want to change that to an exponential, we just start with our base. This is our power, and this is our answer. So you can go back and forth in how you write those. You can have logs of any base. There are a couple of special cases. If you have a log, if you remember we had this number e, and it's 2.71 something, 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 on and on and on. It's kind of like pi, it just keeps going. If you have a log base e of some number x, we write that a special way, ln of x. That's called the natural log. The other special case is if you have log base 10. In that case, we just leave the base off. It's understood to be 10, and this is called the common log. So how do we evaluate these? Well, in a lot of cases, we're just going to use our calculator. If we have the ln of 425, we're going to punch that into our calculator, and we're going to get approximately 6.05. Now, how would we write that as an exponential? Well, the base here, it's a natural log, so our base is e. This is our power. Since it's an approximation, we'll leave it as an approximation. It's approximately equal to 425. Now, what happens if you don't have all the things you want to actually solve? Well, we're going to just talk about one way to do that today, and we'll talk about a different way tomorrow or next lesson. So let's look at this. If we have this problem here, we want to know what y is, then the best way to do that, or one way to do it, is to rewrite it as an exponential. And then if we just take this number, 4,096, and divide by 4 and figure out how many times we have to divide by 4 so that we know what y is. And we end up with y is 6. We divide this by 4 6 times. So divide by 4, 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 divide by 4. And you're going to get your answer. Okay, and so y equals 6. If we have, let's say, log base 5 of 78,125 equals y, and we want to know what y is, we rewrite this as an exponential. 5 to the y power is 78,125. And then we want to figure out what our y is. We divide by 5, divide by 5, divide by 5, until we see how many times we have to go down. So we end up with y equals 7. Make sure you go back and check these. Type it in, 4 to the 6th, and check. It's 4,096. 5 to the 7th, it's 78,125. Let's try one more. What if we have log base 12 of 1 over 144? We want to know what that is. Well, again, change it to an exponential and figure out what y has to be. Well, we know that 12 squared is 144, and we know that a negative exponent is going to put it in the bottom. So that tells us that y is negative 2. And that's really all there is to logs. The biggest thing you need to know right now is how to go between the logs and the exponentials, and to understand that they're inverses of each other and therefore reflections over y equals x. Make sure you've read this section in your book and taken notes on all of it, because we'll check those next class period.